When we think of mountains, we might imagine tall, snow-covered peaks that look like triangles. And when we picture volcanoes, we might think of tall, pointy cones with smoke coming out of the top. But not all mountain ranges look like this. Some are much more rounded, and some volcanoes don't look like cones at all. They look kind of like bowls filled with lots of ash. In fact, there are many different types of mountains and volcanoes, and they all form in very different ways. Now, have you ever heard of a place called the Pacific Ring of Fire? This is an area around the Pacific Ocean where there's a lot of volcanic and earthquake activity. The reason for all this activity is something called subduction. So in this video, we're going to learn about subduction zones and how they form many of the world's unique mountains and volcanoes. But first, let's talk about plates. You see, the Earth's outer layer, or the crust, isn't one solid piece. It's made up of several large and small pieces called tectonic plates. These plates float on the Earth's mantle, which is the layer below the crust. And the plates move very slowly over time. They can pull away from each other, they can push together, or they can slide past each other. Sometimes these interactions cause the crust to crumple up like a piece of paper. And when this happens, mountains form. Where the plates come together are called plate boundaries, and there are three main types of plate boundaries. At divergent plate boundaries, the plates move away from each other. At convergent plate boundaries, the plates move toward each other. And at transform plate boundaries, the plates slide past each other. Now, in this video, we'll focus on what happens at convergent plate boundaries because that's where subduction happens. Let's take a closer look at these boundaries. Here, two continental plates are colliding. Because continental crust is less dense than oceanic crust, one of the plates will begin to dive under the other. When this happens, we call it subduction. The plate that dives down is usually the older, colder, and denser plate. The overriding plate is the top plate, and it's usually the younger, warmer, and less dense plate. So let's say the two plates colliding are both pieces of continental crust. In this case, neither plate will melt, but the collision will cause the crust to buckle and fold, and this will form a mountain range. An example of this is the Himalayas. The Himalayas are formed by the collision of the Indian and Eurasian plates. Neither plate is melting here, but the collision has created one of the tallest mountain ranges in the world. Next, let's say that one of the plates is made of oceanic crust, and the other is made of continental crust. In this case, the denser oceanic plate will usually melt as it begins to subduct. As the oceanic plate moves deeper into the Earth, the pressure and temperature increase. Eventually, the rock of the oceanic plate melts and turns into magma. This magma is less dense than the surrounding rock, so it rises to the surface. Where it reaches the surface, we get igneous rock. Igneous rock is formed from the cooling and hardening of magma or lava. For example, here an oceanic plate made of basalt is subducting beneath a continental plate. Basalt is a dark-colored igneous rock, but after it subducts and turns into magma, it erupts as granite. Granite is a lighter-colored igneous rock. So if we were to look at the rock layers here, we would see that the older, darker-colored rocks are on the bottom and the younger, lighter-colored rocks are on the top. This is called accretion. As the oceanic plate continues to subduct, more magma is generated and added to the pile of igneous rock. Over time, this forms a mountain range called a volcanic arc. The Mariana Islands are an example of a volcanic arc. These islands are formed by the subduction of the Pacific Plate beneath the Philippine Sea Plate. The rock of the Pacific Plate melts and magma makes its way up through the Philippine Sea Plate. There it erupts and creates new igneous rock. The oldest rocks are found on the northwest side of Guam, and the youngest rocks are found on the southeast side of the Mariana Islands. Volcanic arcs are usually found parallel to the trench. A deep valley called a subduction zone trench is found near the point where the plates collide. Let's take a look at one last example. Here, both plates are made of oceanic crust. As these plates collide, the older, colder, and denser plate begins to subduct. As it subducts, the rock melts and becomes magma. This magma creates a chain of volcanoes on the overriding plate. Over time, these volcanoes form a group of islands. Japan is an example of a volcanic island arc. Japan is formed by the subduction of the Philippine Sea Plate beneath the Okhotsk Plate. The rock of the Philippine Sea Plate melts and magma erupts on the Okhotsk Plate. There it cools and hardens and forms igneous rock. The oldest rocks are found on the southern part of the islands, and the youngest rocks are found on the northern part of the islands. So just by knowing the type of crust that's involved in the subduction process, we can predict what type of landforms will be created. If two continental plates collide, we know that neither plate will melt. Instead, the collision will form a mountain range. If an oceanic plate and a continental plate collide, we know that the oceanic plate will melt and will end up with a volcanic arc. Finally, if two oceanic plates collide, we know that the older plate will melt and will end up with a volcanic island arc. Now we know how subduction zones create different landforms, but why do they create such unique and interesting volcanoes? Let's take a closer look at what happens to magma as it moves from the Earth's interior to the surface. Remember that when magma reaches the surface, it's called lava. The type of lava that erupts from a volcano depends on the amount of water and gas in the magma. For example, if the magma has a lot of water and gas in it, it will erupt explosively and create a stratovolcano. Stratovolcanoes are tall, conical mountains with steep sides. Mount Fuji in Japan and Mount Shasta in the United States are examples of stratovolcanoes. But if the magma doesn't have much water or gas in it, it will erupt less explosively and create a shield volcano. Shield volcanoes are much broader and flatter than stratovolcanoes. Mauna Loa in Hawaii is an example of a shield volcano. The shape of a volcano also depends on the consistency of the lava. If the lava is thick and sticky, it will pile up and create steep sides. But if the lava is runny, it will flow out over a large area. In general, the further away a volcano is from a subduction zone, the less water and gas will be in the magma and the runnier the lava will be. So volcanoes that are close to subduction zones tend to be tall and steep, while volcanoes that are far away from subduction zones tend to be broad and flat. So what do you think? Which type of volcano looks the coolest? I personally like the tall, pointy ones. But if you want to learn more about volcanoes, you can click here to watch another video. Thanks for watching. See you next time.